But this is last questions, and we are looking at the last question for November 2018 Series 1 for Cambridge Pure 1 Mathematics. Our function is x minus 3 squared minus 1. And we have our little graph on the right hand side, which I've just drawn for myself. We know it is a one-to-one function, so it's only going to be on one side, the left or right. And our turning points are 3 and minus 1. Just think of completing the square. So we'll put in our points there, and we know that x is less than a. So that's another thing we need. We need the greatest possible value of that a. When x is equal to 0, plug in that value and you'll get the f of x value, or y, as 8. So I've put on the graph as well. I don't think it's relevant right now, but have it there either way. And we will be looking at that aspect, especially the left-hand side of the graph, for the next few parts, I believe. So the maximum or minimum in this case, is equal to 0. So x is equal to 3. So of course, a is less than or equal to 3, based on our highlighted part at the top as well. It is given that a takes the greatest possible value, find the range of f, and find an inverse as well there. So again, discussing the max or min in this case, so the minimum, f of x is equal to x minus 3 squared minus 1. We can replace x minus 3 squared with 0 at the point where the minimum is. So f of x, or y, but f of x is equal to 0 minus 1. So y, in this case, is greater than minus 1. And so now we look at the inverse. So just move and cancel the terms on the side you need. So we move the square, cancel 1, minus 1 I should say. And then lastly move over your 3. So minus 3 becomes 3, so 3 plus or minus root y plus 1. Of course, we want to change our terms or our variables of x to y. So y equals 3 minus root x plus 1. And why is it minus? I said at the very beginning that the domain of you had x is less than 3, so the domain for the original is the same as the range for the inverse. So the inverse should be the same, like less than 3. A quick cutaway back to the first part with the graph, so we can show that the range of f was y is greater than minus 1, and the domain and range of the inverse should make sense as well. We were only dealing with the left-hand side of the graph. Part B, we have a g of 2x, so the daughter function, g of 2x, will go into the g. Let's just adjust our first one. So g of 2x, of course, replace the x with 2x, so we get 2x minus 3 squared. And then we're going to plug it back into g again. So we get 2x minus 3 squared, and then a minus 3 squared as well. And the squared is covering all of that. The second square on the right. And from there, of course, we can simplify. Now, we can do expansion here. So we don't have to do the full expanded brackets if you just check the expression above in the question. So that's to the power of 4. And we have minus 3 times 2x minus 3 squared, and we have 2 of them. Think of it as the same as when you have the two x variable parts in your file method in GCSE. So minus 3 minus c go together. That's b is equal to minus 6. And of course c we already have there is equal to plus 9. So there's our values, the constants for b and c. Hence denotes that we'll be using the answer, or part of the answer, from the previous question. So we have the expansion done out, but we have to simplify it right down. For the first 2x minus 3 to the power of 4, we're going to have to use the binomial expansion. We'll just race through the next part of the binomial expansion. The 4 over 0 is the NCR function in your calculator. you should have ascending and descending parts for your exponents. So just make sure you have a look over that and take care of the minus signs as well. As I complete the simplification of these terms, we then add in the next part, and I'm also going to multiply the 2x minus 3 squared out in the next step just to have it ready. And from there we can bring together our coefficients for x squared and x, and also the constants as well. Now I'm just going to highlight that part that I've changed, so I expanded that out to 2x minus 3 squared. And then we just simplify everything down, and you're going to next just put together your like terms. So the coefficient for x squared, for x, and your constants, and from there that should be your final answer. So just make sure you do that properly, and of course use your calculator. Make it as easy as possible. And that's your final answer there for the expansion for GG2x. And we've simplified it as much as we can. In our second to last question from 2018 in November, we have a curve and a line from A to M. M is a stationary point and A crosses at the y-axis. And we have to find our derivative and we have to integrate as well. So there's our function just rewritten with a clear exponent for easier calculation. So dy over dx, we are going to find the derivative of this function. So half times 3 times 4x plus 1 to minus a half, it's n minus 1, and of course then we have multiplied by the inside of that function, which was 4. So 4x plus 1, the inside part was 4, and minus 2x becomes minus 2. So now if we simplify that out, I've multiplied by 4 as well, so that's pretty much it, and just rewrite it then just to make it more palatable for a further step if we need. And also that's the convention anyway. So there we go, that's our derivative. Next up, integrate the same function. So 3 times 4x plus 1. So we'll have our exponent of 1/2 plus 1, which is 3 over 2, and of course that 3 over 2 has to go under our constant at the front as well. Keep in mind with the chain rule, we originally multiplied by 4, so now we need to divide by 4. And lastly, we've minus 2x to the power of 1, so 2x to the power of 2, divide by 2, and plus c. Simplify all of that. 3 divided by 1/2 is 2. 2 over 4 gives 1/2. So we could put our 4x plus 1 with the 3 to the power of 2 over 2. And then we have those other parts as well. So 2 divided by 2 is 1 plus c. So 4x plus 1 to the power of 3 over 2. Divide by 2, just simplify that bit, minus x squared. It's likely that we're dealing with definite integration here, so we probably don't need the c, but put it in there anyway if you want. And that's part 1. We've obtained the expressions for the derivative and we've integrated that as well. So find the next coordinates of m. So if we remember, m was a stationary point, it's a maximum for this curve that we had. And of course the maximum means that dy over dx is equal to 0. So we take that function that we made, you can see it just above anyway. So minus 2 equals 0, we'll just move that over, cancel minus 2 on both sides, so we get it equal to 2, and simplify from there basically. Just be careful with that square root sign I suppose, but really this stuff should be okay. So 4x plus 1 is equal to 9, because 3 squared is 9, x is equal to 2. And you can substitute that back in then into your original function of y. Just make sure that that top layer for your square root goes across to the right place. And so y is equal to 5. So the coordinates of m were 2 and 5. And that's part 2 for this question. Next up, showing all the necessary working, find the area of the shaded region. So let's go back to our picture or diagram. So we can see that from A to M is from 0 to 2. And of course a, if you just plug in your values for a where x is equal to 0, you'll get 3, and we were given that y was 5. So we already found the values of 2 and 5 here just previously. We have a trapezium and we have another part that we have to integrate for, which is part of our function. So when we integrate this, we're going to be integrating all of it, and we'll subtract the trapezium area, and that'll give us the shaded region. So I'm just putting in here the integration, and of course our boundaries are from 2 to 0 or 0 to 2 on the x-axis, and you just plug in your 2 and your 0 onto that. Again, you can do this in 2 steps on your calculator. Just be careful and separate it out properly with the brackets. So 0, and then again minus 2 times 0. No, actually, to change that. 0 squared, sorry. And that's that, and you'll get the final answer of 9. That's nice and neat. And next, onto the trapezium. I'll just draw it out. So we went from the origin to 2, and the heights went up 3 to 5. And again, it's the same as a rectangle and triangle, but you know what a trapezium is, of course. So 3 plus 5 over 2, or times a half, times the 2, which is the height, in this case, along the bottom, and we get 8. So of course, our full integrated region, take away the trapezium area, and we'll get that little shaded region, which was 9 minus 8 equals 1. 1 unit squared. And just for reference, here's a quick look back at the diagram, just in case you need to see it more clearly. In our third last question from November 2018, Series 3, we have to express 2x squared minus 12x plus 11 in the form for completing the square. So just be very careful with the constant at the front, so separate it out with the brackets. When you've separated out the constant at the front, you can use the formula, as you can see on the right hand side here, a little more easily. So we have 12 over 2, and now we have 12 over 4. Just be careful with that bit there. So 12 over 4 is 3. The next part of the formula is minus 3 squared, which is minus 9. And again, that is part of the expansion with the constant at the front. So be careful there with that. So of course, we'll end up with minus 9 times 2, which is minus 18, plus the 11 that we had originally. So our final answer is 2 times x minus 3 squared minus 7. And we've just expressed it in the form that it asked as well. The function f is defined by 2x squared minus 12x plus 11. We have x is less than or equal to k, constant of k. We have to find the largest value for that, and we also have a one-to-one function. So largest value would give me the indication that we might be dealing with a max or min. We know it's quadratic. We can draw a little quadratic there, and we have already completed the square. So we know that our turning point would be 3 and minus 7. Just looking back at the first part of this question. So just put in 3 and minus 7 in some little sketch. It doesn't have to be too clear. Just make sure you know how it looks. And from there, you should be able to see that k is actually equal to 3. So our max value, the largest value, is like x minus 3. So x is equal to 3. Like x minus 3 equals 0, x equals 3. So k equals 3, but just be careful here. X was less than or equal to k, so k is less than or equal to 3. So we're looking at the left part of the graph from 3 over, because it's one-to-one, cutting the graph vertically. So for this value of k, find the inverse and its domain. So we'll just rewrite our original first part there, where we found our coordinates for the turning point, and we also completed the square. And we'll just rearrange it all now. And this should be straightforward enough. Just bring everything across and get x on its own, and then we'll change that back. So we'll substitute x back into y, so that we get the inverse of f of x. So x could be positive or negative, but I already said we're dealing with a one-to-one function here, so we're dealing with the left part of the graph. So we're actually going to have an answer of 3 minus root x plus 7 over 2. And a further way of looking at this is just to think of your domain range. The range of f is minus 7. The domain of its inverse, of course, will be minus 7. So whatever way you look at it there, they would be the same. So that's why we have 3 minus root x plus 7 over 2. That's the third part of this. And lastly, there's a fourth part. We have a number of details. So we already know that x was less than or equal to k, and it says that k is 1, so x is less than or equal to 1. We have a function for f of x that we had already, and we also have a function for g of x, which is x plus 3 in this case. So we'll plug in the x plus 3 of g of x into our 2 times x plus 3 squared minus 7, which was our f of x. That's our composite f g of x. And that's that there. And then, of course, we can just simplify those 3's out. So we get 2x squared minus 7. And so we know that g of x is less than or equal to 1. Because x is less than or equal to 1. So g of x is x plus 3. So just putting them together, x plus 3 is less than or equal to 1. X is less than or equal to minus 2. And so in that case, p is less than or equal to minus 2. And if it was any bigger, g of x just wouldn't fit. So the restriction is there for the x, as we see. That is the third and last question for November 2018 for Cambridge AS Pure Mathematics.